Good afternoon. Today, our lesson about basic calculus, we will talk about limits. Will be a series of lecture about basic calculus. We will talk about limit today, and maybe next week we will talk about derivatives, and the next we'll talk about integration. Now, what is limit? The definition of limit is the limit of a function of x as x approach t is L, and will be written like this. LIM, that's for limit, x approaching c for the function x equal to L. What we mean by these things? Let's talk about this graph, okay? And this is a function, okay? It's like this. And then we will see if there is a limit in a certain point. This is the first example, okay? We want to test if x is equal to -3, there is a limit, okay? This is limit of x approaching -3. This sign up, negative sign, meaning I am approaching that x from the left side. I'm coming from this direction, okay? If I go from here until I will reach this one here, I will reach how much my y? My y is 2. That's why limit of x approaching -3 from the negative side, the left side of this f of x is equal to 2. Now, what about the second one? Limit of x approaching -3 from the right side, meaning I will go from this direction. And then until I will reach, like this, until I will reach x equal to -3, and then I will find the answer also also 2. Now, what is the limit of x approaching 3? I will look first to the left side to give me 2. From the right side 2. Therefore, the limit of x approaching -3 is equal to 2. Okay, what is the function of -3? It is also 2. Now, let's get another example. The other example is x approaching 0. This is the 0 of x, okay? This is the 0. If I approach 0 from the left side, meaning I'm coming like this, okay? Where I will reach here. When this is 0 here. And this one is 1. Okay, if I approach x -0, okay, this is, there is some mistakes here. Okay, this one is 0. Okay, this is no sign. Okay, from this is a typical. Okay, from this 0, we will have 1. If you approach 0 from the left side, meaning coming from here, you will reach 3. You see? Okay, there is 0. Okay. Now, so it's a mistake. Okay. Now, we can see, if we come from the left side, you will reach 1. If you come from the right side, you will reach 3. 1 is not equal to 3. Not like in this case. Okay, because he said should be both sides equal to L, which is the same number. Now, since they have different answer, that's why we will say the limit at 0 of this function does not exist. There is no, the function of 0 is this one, not this one. Excuse me. Now, let's get another example. That example here. What is the limit? The limit of x approaching 2 of this function. This is 2. Okay. If I come from the limit, okay, the limit of x approaching 2 from the left side of this f of x, and then I will look also for the limit of x approaching 2 from the positive side of the f of x. Now, this is 2. I am going from this direction, okay, from this direction coming to 2, and then I will find it is equal to 3. But if I come from this direction, from the right direction, I will approach negative 2. Therefore, we can say the limit of this function when x approaching 2 does not exist. There is no such. If you want here, example at negative 4, you can see if you are coming from the left side, you will reach 1. If you come from this is from the left side, from the right side, you can reach 1. That's why there is a limit here. Okay, this is if we have a function in a graph. What about if I have a function, written function? Okay, this is how to apply. Okay, let's start with this one. This is a function, okay. Okay, this is a function, and I want to find the limit when x approaching negative 1. This is very easy. You can just substitute by negative 1. It will be negative 1 cube will give you negative 1 minus 2 times negative 1 plus 3. Okay, this one will be 2 plus 3, 5 minus 1 will give you 4. Very easy. Okay, but I don't want to do it like this. I want to do it by table, the same what we saw in the graph. I will approach this negative 1. This is the negative 1. I will approach this one from this direction, and then I will approach it from this direction. Okay, now since this is negative 1, less than negative 1 is negative 1.1. And then I will go slowly until approach 1. I will not go to 1, negative 1. I will not go to negative 1. Okay, but I will try to go to the nearest, very near to negative 1 from this direction. You can see here, each time I will be nearer to negative 1, I'm approaching 4. This one, maybe it will be, if I make it bigger, it will be maybe 3.999999999, something like that. Okay, that's how it works. Okay, Now you can see from here, it is I am approaching 4. If I come from this direction, if I come from this direction, if I don't reach 4, meaning does not exist. But let's see. This is here, I'll start from negative 0.9 and going slowly to negative 1. And then I found it is also give me 4. Meaning here, this function has a limit, and that limit is at 4. Okay? Because this one equal to this one. If they are not equal, like example, if this one he will go to 4 and this will go to 7, at that time it does not exist. Okay? But you can see this one, how much I come nearer, I am approaching 4. Okay? This is easy. Now, what about this one? This a few different. Because if I put here 2, it will be 4 plus 2 minus 6 is 0. Okay. And down is 2 minus 2, 0 also. And now 0 over 0 is a problem. It is undefined. That's why we cannot substitute 2 directly, like what I did here in this case. This one cannot be. Okay, let's see if there is limit or exist or not exist. Now, let's approach 2 from the left side. Before 2 is 1.9. Okay, 1.9, 1.99, 1.9999, and 1.99999. Okay. Now, I make it bigger. Maybe some people, they are using cell phone to watch. Okay. When you'll be coming to 4, okay, like in this case, okay, you are approaching 5 because see, 4.9999999. Okay. Now, what about if I approach from here, which is more than 2, 2.1 and 2.01, 2.001, and so on. You can see here, both of them, I am approaching 5 because this is 4.9999. If I continue, it's very clear, I am going to 5. And this one is going to be 5.000000, meaning I'm approaching 5. Okay? Meaning the limit of this one, it's going to 5. Here, if you go here, we are going to 5. Okay? This one, it will give you here 5. Okay? This one is different here. Okay? Now, another one. Now, let's see if we have, okay, this function, sine x divided by x. By the way, here, when you make your calculation, be sure your calculator in R, right? Not in degree, okay? Now, the limit of x approaching 0, sine x, when sine 0 is 0, and this is 0, 0 over 0 cannot be. If there is no limit, let's see. Now, I will approach this one from the left side. Okay. I will go from 0.1, negative 0.1, negative 0.01, and so on until I will reach 0.00001. Okay. This one, if you make it a few bigger, actually, if I use a calculator here, I can show you. Let's add more decimals, okay? you can see he's approaching 1. Okay, if you go more, it will be approaching 1. Okay, and now if you come from the other side, okay, to 0 from 0.1 and 0.01 and so on going here, it will end here actually with 1. If you give more data, you can see this is smoother because it's going like that, going down. Okay, now this is very important thing in this limit. You should put in your mind limit of x approaching 0 of sine x over x is equals to 1. This is very important thing. We will use it in the future. Okay, let's go to the rules. Now, the rules or the limit laws is like this. It has a limit. The first one I talk about how to use graph. Later we talk about how to use the tabular. And now we will talk about the laws. Law number 1, the limit of x approaching a any number, a real number, of constant equal to that constant. Example, the limit of x approaching 3 of 5 is 5. Why? Because if you draw that one, this is how it looks like when you draw. This is 5. Okay, y equal to 5. Whatever x here, it will give you 5. Okay, this is the first law. Second, he said when limit of x approaching a of x here is a linear. Okay, this is y equal to ax. Okay, it will give you a. Example, the limit of x approaching 3 of x, it will be 3. Because if you draw this one, it's also the same. This is the 45-degree linear. If this one is, because this one here is y equals to x, okay, if this one is a 3, this one will be 3 also. Okay, this is the second law. Law number 3. Law number 3. The constant multiplication. Meaning, if you have a limit of x approaching a of a constant k multiplied by the function is equal to that constant, you can take it outside, limit of x approaching a of f of x, okay, which is equal to the value of this limit, which is L, times that constant. Example, limit of 5x, I can get 5 outside, and then I will find the limit of x when x approaching 3. The 5 is here. The limit of x approaching 3 of x is 3. You multiply it will be 15. You can do it here directly. You will get also the same. But this is the law. Now, let's get the next law. The next law is said the sum and difference is law. If you have a limit of x approaching a of the first function plus or minus of the second function, you can chop it to two limits. Okay, limit of x approaching a of fx plus or minus limit of x approaching a of gx, which will equal the value of this limit plus the value of this limit. The value of the first one was m and the second one is m. Now let's get this example. The limit of x approaching 3 of this function, which is 4 plus x. Now I can chop it to these things. The first one will be the limit of x approaching 3 of 4 plus, because this one is plus here, okay, to be plus, the limit of x approaching 3 of x. Okay. Now this one, I will follow this rule, the one here, which is telling me the answer is 4. And this one, I will follow this second law, which is will be 3. 4 plus 3 is 7. This is the law of the sum. The law of a product, if you have a two function multiplied by each other, okay? The limit of x approaching a of f of x times g of x. You can divide them. It will be limit of x approaching a of x times the limit of x approaching a of gx. And then it will be, the result is how much the result of this limit times the result of the second limit. Now, example. Limit of x approaching the 3 of, open parenthesis, x plus 1 times x minus 1. Of course, you can multiply it here and you can follow the rule here. But we want to apply the rules here of the product. Okay? Now, it will be the limit of x approaching 3, because this one here, the first function, which is x plus 1, times the limit of x approaching 3 of the second function. Okay? And now you can solve it. This one will be 4. Okay, you just follow the rules here up. It will give you 4, and this one will give you 2. 4 times 2, and then the answer will be 8. Okay, this is 4, and this is 2. Okay. Now, question law, he said, if it is a function of x divided by function of gx, okay, you can separate them also, and then with one condition, m should not be 0, because you cannot divide by 0. Okay, this is example. Okay, and then you will find how much the answer of this one will be 2 plus 1, 3, and this one is 2 plus 2, 4, and this answer. Now, this is the rules. We can use it and find any limits. Now, let's get some exercises. Okay, I will get some exercises, but I will take my exercises a few different, a few difficult one, because the other ones is easy. Just you substitute or you follow that laws and it will be easy. But normally there is like example, limit of x approaching 0. You should have a piece of paper and then you solve with me. That's why you can practice when I am, because I will give you time to solve it. Let's say this one is square root of x plus 9. This is both of them enter the square root, minus 3 divided by x. Now, let's look at this one. If I substitute by x directly here by 0, it will be square root of 9, which is 3. 3 minus 3 is 0. And then divided by 0 cannot be. Okay? We cannot solve it by following this rule. We need to modify. Now, to modify this one, if you see something like that, we can do it like this. Okay? I will look to this one. Okay? What I will do, I will multiply it by square root of x plus 9 plus, you see, this is minus, I use a plus, 3. Because if I multiply it, I can get the difference between squares. If I multiply it by this one, I need to divide it by the same amount. Because if you multiply by anything by 1, it's okay. Nothing will happen. Okay, 9 plus 3. Now, let's see what will happen if I multiply them. If I multiply them, it will be limit of x approaching 0. Now, this times this one, it will give me x plus 9 square root whole square minus 3 square. If you open this one, it will give you this one. Okay? The down, you have x times square root of x plus 9 plus 3. Okay, let's open it. This is limit of x approaching 0. Now, up, what we have, this square, it will be x plus 9 minus 9. Okay, this one will eat this one, remaining only x. Down, what I have down, I have x, open, x plus 9 plus 3. Now I can cancel this one, and remaining up is only 1. My final answer here, it will be equals to limit of x approaching 0 of 1 over the square root of x plus 9 plus 3. Now, when it will be 0, what I will get here, this is 1. If this is 0, this one will be square root of 9, which is a 3. The 3 plus a 3 will be 6. The answer is 1 over 6. Okay. This is example if it is like this. Now, let's get another example. Okay, let's get another example. Let's say if I have limit of x approaching 4 of x minus 4 divided by square root of x minus 2. I will give you a few seconds to think about it. If you have a piece of paper, you can find your answer. Okay, that's very easy. Okay, this one, it will be, this will lead me to limit x approaching 4. Now up, I will factor this one. If I consider this one is something like square root x square minus 2 squared. If I factor this one, it will be square root of x minus 2. You should review your algebra if you forget your algebra, plus 2. Okay, down is as it is, nothing down, minus 2. Okay, now this one can't beat this one, and the remaining only this one. That's why the final will be limit x approaching 4 of square root of x plus 2. And then the final answer will be it will be 4 plus 1 is 4. I make a mistake. Okay. The answer will be 4. Okay, because this is square root of 4 is 2 plus 2 is 4. You can solve it by another way. If you want to solve it similar to the previous one, still you can solve it. Like example, you can say, no, I will solve it like this. Limit x approaching 4. Okay, and up is x minus 4. I will not touch it, but down I have x minus 2. Okay. I can multiply and divide by this number, okay, by square root of x. Okay, x square root of this one plus 2 divided by square root plus 2. Okay, this times this, it will be the final answer here, and it will give me something like that. Limit. This is another way to solve it, huh? And both of them you will reach the same answer. Approaching 4. Okay, the one up is x minus 4 times square root of x plus 2. And down, if you multiply this by this one, you will get x minus 4. Okay, difference between. And then after that, you can cancel this one with this one. You will have the same answer what we have up. Okay, this is another example. Now, what about if I have something like limit of x approaching 0 of sine 3x divided by the sine 5x. If you put 0, it will be a disaster. Okay. Now, to solve that one, we will take advantage of this one. Limit of x approaching 0 of sine x. This is can be theta, any one over x. They are the same. Theta, example, and this is theta. It's 1. Now, I want to make something similar to that one. I will just divide this one by 3x. If I divide it by 3x, I need to multiply it by 3x. This is the same. I need to divide it by 5x. If I divide it, I need to multiply it by 5x. Now, what will happen? Okay. This x, it will eat this x. This is 1, and this is 1. The final answer, it will be 3 over 5. Now, to summarize what we have here, okay, and what we talked today about is, today we talk about basic calculus, we talk about the limit, we discuss about the graph, okay, about the graph, how you find the limit from a graph, and then also we talk about the tabular method. If you have a function, how to find this the limit of that function, if it exists or not exists. If it exists, how much, by using these tables. And we talk about the laws of the limits to apply it. And then we have some examples. We solved a simple one. If like this, how to solve it. Then if you have something like that, how to solve it. Okay. Why we talk about this limit? Why it's important? Because next time when we talk about derivatives, we will start with the limit. Okay, that's how you understand the derivative. First, you need to understand this. Up to here, I hope you learn something and have a nice day, and see you in the class. Thank you very much for watching. This is Dr. K.